topic of this video is determining the inverse of a function, and specifically the subtopic, finding the domain and range of a function and its inverse. Alright, in a previous video we found that when f of x equals 4x over the difference 3x minus 7, f inverse of x was 7x over the difference 3x minus 4. Find the domain and range of f and f inverse. Okay, so the first thing we want to be able to do is recall the 4 steps for finding domain. Start with all real numbers, even radicand greater than or equal to 0, log argument greater than 0, denominator not equal to 0. Let's apply that to the function f. There are no even index radicals or logs, but there is a denominator, 3x minus 7. It's not allowed to be 0. So 3x minus 7 is not equal to 0. Adding 7 to both sides, 3x is not equal to 7. Dividing by 3 on both sides, x is not equal to 7/3. If we wanted to express this as an interval, we would say negative infinity to 7/3, parenthesis, union, parenthesis, 7/3, comma, infinity. Okay, let's now do the same procedure for our other function. This is going to be a very, very similar activity. So once again, there are no even index radicals or logarithms, but there is a denominator. So 3x minus 4 is not allowed to be 0. Adding 4 to both sides, 3x is not equal to 4. Dividing by 3 on both sides, x is not equal to 4/3. So as an interval, this would be from negative infinity to 4/3, union 4/3 to infinity. All right, now to the new skill. We learned that the domain of a function f is the same as the range of its inverse. So that allows us to take the information in this box here and place it in this box here. This tells me that the range of f inverse is equal to negative infinity, comma, 7/3, union 7/3, comma, infinity. Similarly, we know that the domain of f inverse must tell us the range of f. So this information goes in this direction, and we would have negative infinity, comma, 4/3, close parenthesis, union, open parenthesis, 4/3, comma, infinity. Now, that is the end of this problem, but I have one more thing to share with you. What we have just discovered is unbelievably important. Very, very important. Up until this moment in the semester, if anyone had asked you, hey, how do you find the range of a function? You would say, I don't know, maybe graph it and try looking at the picture. But there was no algebraic way to find range of a function. Now there is. If someone gives you a function and they ask you for its range, it's a simple 2-step process. Take your function, find its inverse, find the domain of the inverse, and that tells you the range of the original function that you started with. We now have a new skill, a new tool that we can use all throughout the semester.